United States manned spaceflight program, there was, in the second three-month period of 1968, a continuation of the events that signal a gathering momentum. It was a period of intensified testing to qualify Apollo equipment for manned flight. A period of exhaustive investigations of problems and widespread efforts to solve them. A period of preparation and checkout of flight hardware. A period of stepped-up activity in anticipation of the first manned flight in Apollo. Many of the most important events in the report period were related to the unmanned flight of Apollo 6. The mission, which was the second for the Apollo Saturn V, was launched from the Kennedy Space Center on April 4th, 1968. Major objectives were to prove out the vehicle's structures and systems in flight, and to prove out the command module's heat shielding during re-entry. All of a similar set of objectives were met in the first Apollo Saturn V flight, and while most of the objectives were met in the second flight as well, there were several significant problems. There was an unacceptably high level of an up and down vibration, or oscillation, along the vehicle's length. This occurred late in the first stage burn. Several square feet of material separated from the structural shroud enclosing the lunar module. Two of the second stage's 5 J2 engines shut down early, and the third stage's single J2 failed to restart for a planned second burn. Nonetheless, all separations were normal. Other systems functioned properly, both for the launch vehicle and the spacecraft. Some of the most valuable photographs for the Earth Resources Survey program were recorded during the second orbit by a camera pointed out a window in the command module. Finally, in the Pacific Ocean, the command module was recovered in excellent condition. Throughout the mission, a flight crew would have been safe in spite of anomalous conditions. Immediately, attention turned to investigating and solving the problems. The Marshall Space Flight Center was the scene of much of the effort to solve the up and down vibration or oscillation problem. Such oscillation is known as the pogo effect and was a phenomenon encountered in the Gemini program with the Titan launch vehicle. It was dealt with by modifying launch vehicle propellant pumps and lines. In Apollo Saturn V, tests and studies have shown that the pogo phenomenon becomes serious if two basic flight conditions develop. First, the very slight burning pulsations of the first stage engines must occur in synchronization, like the drums of a marching band. Next, the rhythm of the synchronized burning pulsations must match the rhythm of natural structural vibrations. Then, in an effect similar to that produced in the well-known example of a band marching across a suspension bridge, the up and down oscillations of the space vehicle are amplified. They soon reach an unacceptable magnitude. One possible way to solve the problem is by changing the rhythm of the burning pulsations so that it will not match that of the structural vibrations. This led to experiments in which the rhythm of the pulsations was changed by injecting small amounts of helium into the flow of propellants. At the end of June, work on the pogo problem was continuing. A problem which probably resulted from the pogo effect was the separation of material from the structural shroud enclosing the lunar module. It is known that the vibrations imposed exceeded design specifications. To be certain of the cause, however, engineers were continuing their investigations. An entire spacecraft had been combined with the uppermost section of the launch vehicle for a series of vibration tests due to begin in July 1968. Meanwhile, the problems with the second and third stage engines were traced to two causes. One second stage engine and the third stage engine failed when a propellant line to an ignition system ruptured. The failure was essentially duplicated in ground tests when the propellant lines were intentionally ruptured. Already, the lines for future vehicles are being structurally modified. The other second stage engine which shut down did so because of an assembly wiring error which went undetected due to a faulty test procedure. The procedure has already been revised to prevent recurrence. Confidence was high that all the problems could be solved, and a plan for manning the next Apollo Saturn V was set in motion. Accordingly, as the tempo increased throughout the Apollo program, engineers and technicians began preparing the next Apollo Saturn V for a flight crew. The launch vehicle, which had already been erected at the Kennedy Space Center in anticipation of an unmanned flight, was disassembled for modification and additional testing. The second stage was returned to the Mississippi test facility for cryogenic proof testing, which means the stage is loaded and pressurized with super cold liquids, then checked for structural integrity. By the end of the report period, modification and added testing were complete, and all Saturn V equipment was being returned to the launch site with an added measure of confidence. Meanwhile, the lunar module was delivered to the Kennedy Space Center from Grumman Aircraft, and the command and service modules were almost ready for delivery from North American Rockwell. Concurrently, hardware for the fourth Saturn V was delivered to the Kennedy Space Center, and equipment was already in checkout in the vehicle assembly building. At the same time, a second pad at the Apollo Saturn V launch complex was completed and approaching full operational status. The events in Apollo Saturn V were paralleled by the preparations for the first manned flight in Apollo Saturn 1B, a mission to be known as Apollo 7. The Saturn 1B launch vehicle was erected at Complex 34 in April, and pre-flight checkouts were initiated. Progress was interrupted briefly when about a quart of propellant was spilled, resulting in contamination of launch vehicle equipment. The launch vehicle's instrument unit and second stage forward skirt had to be removed for cleanup and inspection. However, the accident would not delay launch schedules. It was in May that the command and service modules for Apollo 7 were delivered to the Kennedy Space Center and were found to be the most technically fit manned spacecraft ever received. The modules were put into testing at once, pointing toward full checkouts with the flight crew before transfer to the launch pad. Even as vehicles were being prepared for manned missions, qualification testing was continuing, aimed at final assurance that all systems and procedures were flightworthy. Still a difficult development task was the injector for the lunar module ascent engine. The injector is the device which delivers propellant into the engine combustion chamber. Problems with the original injector led to the development of an alternate or backup injector. It was announced in early June that the backup injector would be used for the lunar module in the first manned Apollo Saturn V flight. Development will continue for both injectors to assure that a reliable one is ready for the lunar mission. Another series of tests was aimed at completing qualification of the Apollo parachute Earth landing system. This became necessary when the weight of the command module was increased by design modifications to further assure safety. The culmination approached late in June, when the sixth of a group of 7 drop tests was completed successfully. Still being investigated in the meantime was the failure of a vehicle which is a very important part of the astronaut training. It is called the Lunar Landing Research Vehicle and is used for simulating the lunar module flight characteristics and procedures in the Earth's environment. It was during a routine training mission on May 6, 1968, after well over 200 successful flights, that the vehicle suddenly went out of control at a low altitude. Following well-planned safety procedures, the pilot, astronaut Neil Armstrong, ejected to safety. but the vehicle crashed and was destroyed. Investigations into the matter were continuing at the end of the report period, but since other similar vehicles are available, it was not anticipated that schedules would be delayed. There is nothing more basic to the development of manned space vehicles than ground testing. Years have been spent to build necessary facilities and prove out systems before actual missions are undertaken. In June, a major milestone in ground testing was reached in Space Environment Chambers at the Manned Spacecraft Center. For in an effort involving hundreds of people, the lunar, service, and command modules passed rigorous tests, which cleared many of the obstacles to manned Apollo missions. The lunar module tests comprised a series of 4 manned simulated flight operations with a ground test vehicle in simulated space conditions like those to be encountered in Earth orbit as well as in lunar orbit. The vehicle and test equipment performed so well that the manned tests were completed in 1 week rather than the anticipated 2. Soon thereafter, a similar series of manned tests were initiated for the command and service modules, which were located in a second Space Environment Chamber at the Manned Spacecraft Center. In these tests, a 3-man flight crew remained in the command module continuously for close to 200 hours, working and living essentially the same as if they were in space. Preliminary evaluations of data indicated that test results looked favorable, and the stage was set for manned Apollo flight. While a growing amount of equipment was reaching full qualification, hardware of increasingly high technical quality was flowing out of assembly lines with increasing frequency. New spacecraft modules at both North American Rockwell and Grumman were nearing readiness for delivery to the launch site. The supply of both Saturn V and Saturn 1B launch vehicles was more than adequate to support scheduled flights. With the full Apollo capability rapidly coming into being, the work to capitalize on that capability continued in Apollo applications. On May 16th, the Apollo telescope mount controls and display panels were reviewed at Marshall by astronauts and other technical personnel. The telescope will be used for astronomical studies in space, a unique contribution to the physical sciences. In another application of space technology, aerial photographic studies of the Earth continued with infrared color film as well as other sensing mediums. The studies were conducted in the Earth Resources Survey aircraft program. The objective of such studies is to determine how man in space may best acquire data for more efficient utilization and management of the resources of our Earth. This particular infrared photography was the result of studies of agricultural areas in South Texas conducted in conjunction with scientists from the Department of Agriculture. Data such as these indicate that we are not only closing on the goal of manned flight to the moon, but on the broader goal of space flights of immediate benefit to all of us on Earth. And therein is the ultimate aim of our pursuit of knowledge in manned space flight.